Now, aldehydes and ketones that have carbons, say from 3 carbons to 10 carbons, right? So, aldehydes and ketones that have this formula, 3 carbons to 10 carbons, they are liquids. Okay, so let's talk about boiling point then, if they're liquids, right? So, where does the boiling point go for aldehydes and ketones? First of all, is there polarity in the molecule? Yes, there is polarity in the molecule because there is this group, right? So this is partially negative, this is partially positive. Now remember, don't confuse this with hydrogen bonding. Now we're talking exclusively about polarity. So these molecules are polar. Okay, there is a positive pole and a negative pole. Okay, they are polar. Okay. Please pause this video for some time and check your hydrogen bonding. Hydrogen bonding also there is positive and negative. That is also because of electronegativity of oxygen. But that's a different interaction. This is just a dipole or this is just a polar molecule. Alright, so there is polarity in the molecule. Now how does the intermolecular force work? So say there is another carbonyl like this. So this is electropositive, this is electronegative, right? So there is a force of interaction like this, right? And this one will have force of interaction with some other carbon, yes? So this way there is dipole interaction between one dipole and another dipole. So this is a dipole interaction. Now, will this dipole interaction influence boiling points? Yes, it will, because if you take a hydrocarbon, right, that has 3 carbons, just a hydrocarbon, and consider an aldehyde or a ketone that has 3 carbons, right? There is a chance of polarity in this molecule, right? There is polarity in this molecule because this is a polar bond. No polarity here. So this is non-polar. So here there is a chance of dipole interaction like we've seen before. But in this case, no dipole interaction. So this dipole interaction makes one molecule of aldehyde interact with another molecule of aldehyde interacting with another molecule of aldehyde. So there is a dipole interaction as well as, so there's a dipole interaction in addition to London dispersion forces, right? Whereas in hydrocarbons there is only London dispersion forces, right? Hydrocarbons have only London dispersion forces. So there's more interactions in aldehydes. So aldehydes have a higher boiling point, or carbonyl compounds in general have a higher boiling point than hydrocarbons. Now, carbonyls have lower boiling points, but their boiling points, carbonyls' boiling points, are lower than that of alcohols. Why? Alcohols. Why is that? Because alcohols, they also have hydrogen bond, okay, they have hydrogen bond with each other. Okay, so in addition to dipole-dipole interactions, they have hydrogen bonding. So alcohols have a higher boiling point than aldehydes, but aldehydes have a higher boiling point than hydrocarbons. Now, among themselves, as in within aldehyde and ketone families, you have to remember, so just take, say for example, C double bond OH, H, this is methanol, and C double bond O, H, CH3, this is ethanol, right? Which out of these two, among themselves, which will have the higher boiling point? Always remember, if it is the same family, look at the number of carbon atoms. The more number of carbon atoms, more will be boiling point. So boiling point increases with number of carbon atoms within the same family. That is a general rule.